Question 19 again is about the uniform geometry question. In this question, we need to use some property about the rectangle and some parallel line to solve it. In the statement 1, it's claimed that the angle DAE will be equal to DGF. Let's just check whether it is correct or not. First of all, if we focus on two triangles, one I mark by green color, CGE, this triangle, and the other triangle I marked by the orange color, the bigger one, CDA. If you focus about these two triangles, the green and orange triangle, we will know that actually they are the similar triangle. This is because of, first of all, we have one pair of the corresponding right angle. CEG is a right angle because of the perpendicular information given by the question, and then CDA is 90 degrees is because of this is a rectangle. After you have one of the right angle, corresponding right angle, and then after that, we also have one common angle are there. The red color actually is a common angle of these two triangles. Green and orange triangle also have this common angle. So that's why I can conclude, because there are already two pair of the angle, they are equal correspondingly. So that's why the rest of the angle, the pair of the angle must be also equal. And then because of AAA, so these two triangles should be similar. And then now I can do the conclusion. It's like the angle DAC in the yellow, in the orange color triangle, and the angle in the green color CGE, they are actually the same because they are the angle, the corresponding angle of two similar triangles. So that's why these two black in color highlighted triangle should be the same. And then because of DGF is actually the opposite angle, opposite vertex angle of the angle CGE. So that's why I can do the conclusion. It's like angle FGD actually equal to angle CGE because they are vertex opposite angle. And moreover, because the angle CGE will be equal to angle DAE because they are the corresponding angle of the similar triangle. So we can finally conclude that the statement 1, angle DAE will be equal to the angle DGF. So that's why the statement 1 is correct. Then now we take a look about the statement 2. The statement 2 actually is talking about the angles of BCE. Because the statement 1 already finished, maybe we can just try to erase all the information we marked before. Okay, so we highlight about that two triangle by the different color. One is about the new orange triangle BCE. Wait a minute. Okay, BCE. And then the other triangle. Okay, another triangle is actually CGE. This time, these two triangles, they are similar a lot. Okay, let's check. So I will say in this way, if I assume this angle is A, then that means if I assume GCE, this angle is A, then the other part, the angle ECB will be 90 degree minus A. And then because of the perpendicular relationship, we know BE is actually perpendicular to the straight line AC. And then, so that's why we have two right angle there. And then if we focus on the green color triangle, we can also, based on the calculation, to find out that the angle CGE will be also 90 degree minus A. 90 degree minus A. And then now, if you take a look about these two pair of triangle, I think the conclusion again is quite obvious because we already find out two pair of the angles correspondingly they are equal, such as BCE in the orange color triangle is actually equal to the angle CGE. They are both equal to 90 degree minus A. The other angle correspondingly they are equal is actually the 90 degree. That means the angle CEB will be equal to the angle CEG. They are all 90 degree. So because again in these two triangles you already have two pair of corresponding angle, they are equal. So that's why these two triangle, green and orange color triangle right now must be also similar. They must be similar. So that's why it's correct. And then now we go to the last pair of triangle. I'm so sorry that I keep on using green and orange color, but every time I erase all the things I think are still very clear. This time the triangle we need to focus, the pair of triangle we need to focus will be BCE. This one. Okay. And the other triangle actually is FCE. This time, is it these two triangle? Are they congruent? Then we can again check about the information one by one. First of all, because of the perpendicular relationship again, so we will know that they have actually one pair of corresponding right angle. They are actually FEC and then CEB. They are corresponding equal angle. Also right angle. And then because this time, okay, they have also one common length, common side. That is actually CE. CE is a common side in these two triangle. No matter green color triangle or the orange color triangle, they also have the common length CE. So now you already have one pair of equal angle and one pair of equal length. And finally, one thing that we also see they are equal is actually FC equal to the length BC. Why they are equal? This is because of FC is equal to AD. This is the information given from the question. And then because of AC is equal to BC. This is because of this is a rectangle. So that's why finally FC equal to BC. And then now, if you check about the information, you have one side and other side and then one angle. In this situation, in general, is SSA. We cannot say that they are congruent because we don't have any theory about SSA. However, this time because this is a right angle, so it will be a little bit special. We actually not only have side and angle, we have the hypotenuse, common side, and the right angle. So we can say that they are congruent because of RHS block SSA. So that's why the statement 3 is also correct. So now because of both of the statements are correct, so that's why question 19 the correct option should be